This is what would happen to your body if you traveled into space at near light speed. At near light speed, time slows down for the traveler. This means that for every hour that passes on the spaceship, many years could pass on Earth. As the saying goes, time is relative. It depends on how fast you're moving. The faster you move, the slower time passes for you compared to someone who is not moving or moving slower. And the closer you get to the speed of light, the slower time passes. This is called time dilation, and it has been proven by scientists. When you are moving at very high speeds, like close to the speed of light, space and time intertwined in a four-dimensional continuum known as space-time are affected. Time dilation occurs due to the constant change in velocity when an object moves at a significant fraction of the speed of light, which is approximately 300,000 kilometers or 186,000 miles per second. This causes a distortion in the flow of time as perceived by an observer. Imagine if we were able to send spaceships that could travel at near light speed. If these spaceships were to go on a journey of 10 light years and then return, the astronauts on board would have only aged a few years, while decades or even centuries could have passed on Earth. Let us take a closer look at this scenario and explore what would happen to the astronauts and our planet during their absence. Assuming that the spacecraft can travel at 90% of the speed of light, the journey to the distant star system would take approximately 4.35 years from the perspective of those on Earth. However, from the perspective of the astronauts, time would pass much more slowly due to the effects of time dilation. In fact, they would only experience about 4.35 months of time passing during their journey. But here's where things get really interesting. While the astronauts are away, our planet continues to rotate on its axis and orbit the Sun. This means that when the spacecraft returns to Earth after traveling 10 light years, it will actually be orbiting the Sun 20 light years from its starting point. But despite having traveled 20 light years, the astronauts on board would have only aged by a few years. This is because the combination of time dilation and the continuous rotation of the Earth results in a phenomenon known as the twin paradox. According to special relativity, time is relative and the passage of time is affected by the relative motion between observers. In this case, the astronauts on the spacecraft would have experienced time more slowly than those on Earth due to their high speed. When they returned home, they would find that significantly more time had passed on Earth than had passed for them. This is because as the spacecraft approaches the speed of light, time slows down for the traveler. Now let's talk about the shape of the Earth. As the Earth revolves around the Sun, it does so in a path that is slightly elliptical rather than perfectly circular. This means that the distance between the Earth and the Sun varies throughout the year. At its closest point, the Earth is about 147 million kilometers from the Sun, while at its farthest point, it is about 152 million kilometers away. These variations in distance would have an impact on the gravitational force between the Earth and the Sun, which in turn affects the orbit of the Earth around the Sun. Despite these changes, the Earth remains relatively stable in its orbit due to the balance between gravitational force and centrifugal force. Gravitational force is the force of attraction between two objects that have mass. In the case of the Earth and the Sun, the mass of the Sun is so much greater than the mass of the Earth that the gravitational force between them is much stronger than any other gravitational force acting on the Earth. Centrifugal force, on the other hand, is the force that tends to make an object move away from the center of a circle or curve. As the Earth revolves around the Sun, centrifugal force acts on it, tending to pull it away from the Sun. The balance between these two forces keeps the Earth in a stable orbit around the Sun. If the gravitational force becomes stronger, the Earth will move closer to the Sun, while if centrifugal force becomes stronger, the Earth will move farther away. This balance is constantly shifting, but it is always in a state of equilibrium. Throughout the year, the Earth experiences different seasons due to the tilt of its axis relative to the Sun. As the Earth moves along its orbit, the hemisphere that is tilted towards the Sun receives more direct sunlight and experiences warmer temperatures and longer days. Conversely, the hemisphere that is tilted away from the Sun receives less direct sunlight and experiences colder temperatures and shorter days. This variation in the angle of sunlight throughout the year is what causes the seasons to change. In summary, the Earth remains stable in its orbit around the Sun due to the balance between gravitational force and centrifugal force. The changing distance between the Earth and the Sun throughout the year affects this balance, causing the Earth to move closer to the Sun in January and farther away in July. These variations in distance also affect the intensity of sunlight reaching different parts of the Earth, causing the seasons to change. Okay, now back to our story. When the spaceship returns to Earth after traveling at near light speed, the astronauts on board would have only aged a few years, but they would have effectively traveled back in time. For example, if 100 years had passed on Earth during their absence, they would have only aged 4.35 years. This means that upon their return, they would be roughly 95 years younger than the people on Earth. This phenomenon, known as the twin paradox, has been proven through experiments with atomic clocks. Atomic clocks are incredibly precise timekeeping devices that use the vibrations of atoms to measure time. Experiments have shown that time passes more slowly for atomic clocks that are moving at high speeds compared to those that are stationary. This has been demonstrated by placing two atomic clocks, one on a plane that flies around the world at high speed and the other on the ground, observing that the clock on the plane loses a tiny amount of time compared to the clock on the ground. These experiments provide evidence for the theory of relativity, which predicts that time is relative and that it passes more slowly for objects that are moving at high speeds. This means that if a person were to travel on a spaceship at near light speed, they would age more slowly than someone who remained on Earth. If humans ever develop the technology to build spaceships that can travel at near light speed, it may be possible to test this theory in real life. However, it is important to note that traveling at such high speeds would require a tremendous amount of energy and would pose significant challenges. Nevertheless, the potential for time travel through space exploration remains an exciting prospect. It's possible that in the future, astronauts who travel to distant stars and back may return to Earth as much younger versions of themselves due to the effects of time dilation. Let us say that you standing on the platform waving goodbye to a loved one who is about to board a spaceship that will travel to Alpha Centauri, a star system located 4.37 light years away. The spaceship is equipped with a powerful engine that allows it to accelerate to 90% of the speed of light. As the spaceship approaches the speed of light, time slows down for the traveler, meaning that time passes more slowly for your loved one on the spaceship compared to you on Earth. You watch as the spaceship leaves the platform and begins its journey to Alpha Centauri. According to your calculations, the journey should take approximately 4.37 years to reach the star system. However, due to time dilation, your loved one on the spaceship will only experience about 4.35 months of time passing during the journey. As you stand on the platform waving goodbye, you know that you will grow old and perhaps even pass away before your loved one returns to Earth. You think about how much you will miss them and wonder if they will remember you after so much time has passed. Meanwhile, on the spaceship, your loved one is buckled in and preparing for takeoff. They know that the journey ahead will be long, but they are excited to explore the unknown and discover new worlds. As the ship accelerates to near light speed, they feel the G-force pushing them down into their seats. They know that when they reach Alpha Centauri, they will be greeted by a star system that is 4.37 light years away from Earth. But due to time dilation, they will have only traveled through time a few months. Upon their return to Earth, they will find that many years may have passed since they left. Despite the challenges and uncertainties of space travel, your loved one is determined to make the journey and discover what lies beyond the stars. They know that the adventure ahead will be one that they will never forget. And as the spaceship leaves the platform and disappears into the vast expanse of space, you are left on the platform waving goodbye until their return. Thank you for watching. Please subscribe for more videos about space and time travel.